just kidding. Oh my god, you guys thought your sound was off. Alright, I'm not that good of an actor. Whatever. Anyway, my name is Mr. Krause. For the next 20 or 30 or 40 minutes, you can call me Mr. Key. I am the worst of two halves. We make up www.nkinfinity.com. NK for Newman Krause. The better half of my partnership is Miss Vicky Newman, and you can find almost all of our materials at nkinfinity.com. If you want, you can also go here, Algebra 2 or Algebra 2cc commoncore.com. That'll take you to NK Infinity as well, and it'll get you on the road to getting all the things that you need. Anyway, let's get started. We're on Unit 1, Day 6. I'm ready to roll. You're ready to roll. We're ready to rock and roll. Maybe if you're lucky, I'll sing to you today. No, I don't sing. I drink coffee, though. I think I'm on an emotional crash high today because I'm drinking way too much coffee, but that's okay. Let's see. Piecewise function should say it's a function or a relation that has pieces to it. One piece here, one piece there, a little piece here, a little piece there. So it's multiple pieces, pieces of different relations, that are put together to make a new relation function. To make a new relation or function. Anyway, blah, 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 blah. Oh, I hate definitions. Anyway, piecewise functions, a whole bunch of functions that you can put together to make one big function. It's got a little piece there, a little piece there, a little bit there. It's basically not going to be just one parabola or one line or one absolute value or one, whatever. It's going to be stuff. For example, here's a piecewise function. Here is a piecewise function where we have a line. Here's a closed circle and a line. Now, the equation of that line is y equals x plus 3. The slope is up 1, it is over 1, and has a y-intercept of 3. There it is. So awesome. Wait a second, we got another piece. This one has an open circle, and it's going down, and it's almost the same line. Like if I just slid it up, it'd be like the extension of that line, but that's not it. The equation of that line is y equals x plus 2. It also has a slope of 1, and goes, and if you continued this on, it would have a y-intercept of 2. Now, the hard part about Piecewise's functions, yeah, that's some good English there. I got some gooder English there for you guys. Anyway, the hard part about piecewise functions is coming up with the domain. Because our function f of x is going to be defined like this. It's going to be one piece here. This is my first piece, and this is my second piece. Or whatever. You can switch their order. But over here, we have to say, okay, you can only use this one under these conditions. So over here, we're going to have to write the domain, and that, again, is the tricky part. So let's go take a look at x plus 2. X plus 2 is this piece right here. I'm going to do it in yellow. So it's this piece right here in yellow. So what is my domain? Well, my domain says it's going to be at -2 and going off into this direction. So I can only use this function right here if x is less than -2. Not equal to -2, because you'll notice there's an open circle here. All right, that was not too bad. Now let's go to x plus 3. X plus 3 starts here with a closed circle and goes there, and that starting point is the same starting point. Now that doesn't always happen. It doesn't always happen at the same place. But here it starts at negative 2 and goes forever and ever to the right. So that would be x is greater than or equal to negative 2. Now the reason it's equal to is because it's got the filled in circle. Okay, so that's, you know, a little bit. Let's keep going. Oh, see, I don't baby you. Now I'm going to give you the f of x, but I'm not going to give you the function. Wow, great C, Krause. Function or functions, or the domain that it restricts it under. We have to figure that out on our own. We need some delicious Dunkin' Donuts coffee. But before I get started on that, let me drink some coffee. I think I just leaked some coffee. I'm going to take a pause and I'll be right back. Come on, be honest. You missed me while I was gone, didn't you? For you, that's like 2 seconds. For me, it's a minute. I save the video, I do a little video editing, and then I come back. And here I am. For you, it's like that. I just change heads. All right. So we have 3 pieces to this function. We got this piece here, 1. We got this piece in the middle, 2. And we got this piece over here, 3. So we have 3 pieces to this function. That's why I made this curly bracket. Actually, my counterpart, Miss Vicky Newman. Oh my God, she's awesome. Maybe we should have her head pop in. Maybe I'll have her head pop in this video. Anyway, she created this one. So let's see how we're doing. Let's just talk about this piece. This piece starts at negative 4, closed circle, and it goes this way. Now, if this was a full complete line. Now that's a horizontal line. I got to remember horizontal lines have the equation y equals, and then the equation of that line, and the equation of that line would be negative 2. So y is equal to negative 2. And there's no x because the slope is 0. The slope is 0 for this line, so we don't need an x in this case. But y equals negative 2, and y is equal to negative 2 from negative 4 to negative 2. So I'll put a comma. Negative 4 is less than x is less than negative 2. Now, do we need the equal to? We got closed circle here, and we got closed circle here. So we'll put equal to on this one. Maybe I won't put it on that one. I think I can make, it doesn't matter in this case, because notice we're going to extend on this one. I could put an equal to here if I wanted to. But I can't put it in 2 different places. So I'm going to leave it off. You'll see why in a second. Now we're going to do this piece. The slope of this line is up 1 over 1. So that's y equals x. Maybe I will put it in. So since this one started at a closed circle and ended at a closed circle, I'll put it in. I'll show you why in a second. I'll show you why what kind of difference you can make in a second. So this equation is y equals x, and it's got a y-intercept of 0, so plus 0, but I don't really need the plus 0, so y equals x, comma, starting at negative 2, less than x, less than 2. Now, even though this starts over here at a closed or closed-in circle, I have to decide which one's going to get the equal to part. Is this piece going to get the equal to part or this piece? I decided since I put the equal to here, I can't put it here as well because you can't be in 2 places at one time. So you have to make a decision. Is it going to be in the first one or is it going to be in the second one? And if I didn't put it here, ooh, what happened? If I didn't put it here, let's say I erase that. Oh, man. Let's say, oh my gosh. It's going crazy. Let's say I just put x less than negative 2 here. Then I could put the negative here. But I didn't do that, so. What is going on, kids? All right, x less than or equal to negative 2. I put it there. So therefore, I can't put it in this one. So, but this one has a closed-in circle, so why don't I put it in this one, just for fun? And again, I don't have to put it in this one, I can put it in the next one. All right, now I got to come up with the equation for this line. So this is a little bit of a tricky one. Let's see here. It's coming down, so I know my slope is negative, y equals negative. It's going down 2 and right 1, so negative 2x. If I continue this up, it looks like it would be 6. Looks like it's plus 6. Now, I can verify that by doing point slope formula. So my slope is negative 2, and my point is 2, 2. Got a 2, 2. So I'll do y minus 2 equals negative 2x minus 2. And I'll just use this formula, and I'll try to figure out if it is, in fact, plus 6. I think it is, but might as well be sure. Minus 2 equals negative 2x, and this is negative 2 times negative 2, which is plus 4. I add 2, and I add 2, and I get 6. So, yeah, it is negative 2x plus 6. So, negative 2x plus 6, comma. Now, we're going to start here at 2, less than or equal to x, less than 4. Now, since I already included the equal to here, I can't include the equal to here as well. It can't be in two places at once. You got to make a decision. But I do have to include it here at this one right here because that's a completed filled-in circle. So equal there. There it is. Like I said, it gets a little bit more complicated. All right, I'll be back. By the way, I never asked, how do you like this logo? It's pretty cool, right? NK Infinity. Pretty cool infinity. Oh, or pretty cool logo. I like it. All right, here we go. Moving on because nobody cares. Again, I can call my function anything I want. I am recording, right? I could call my... Ooh, there's my dog howling at the police or the fire engine. He loves it. When my dog howls at the fire department and I'm doing math videos for my kids across New York State and my dog's howling, I drink Dunkin' Donuts coffee. If only they were a sponsor. Just saying. Anybody know anybody that owns a Dunkin' Donuts franchise that would like to sponsor a poor, upstanding math team of Newman and Krause? We're like that law firm here, Newman and Krause. And we have infinite problems. Oh, yeah, we kind of do, don't we? Oh, back to math. Oh, okay, here we go. All right, so here we go. We got this piece 1 and 2, hence the not-so-big curly brace here. This one's easy. I'm going down 1, over 1, so my slope is negative 1x, and my y-intercept is the origin, so it's just negative x. Okay, negative x. And while I'm at it, why don't I just do this piece? This one's going to be y equals, it goes up 1 and over 2, so that would be 1/2 x plus 0, but I don't need that. So 1/2 x. Now I just got to come up with the domain. So let me get rid of all my craziness. This one is going to start here and end here. So we'll go from negative 1 is less than or equal to x is less than or equal to 0. Since they're both filled in circles, I'll put both equal to. By the way, anytime you're doing one of these, it's always x in the middle. If ever you're going to be like end point to end point, x goes in the middle and it's always less than symbols. You know, because if you just read this half, it's x is less than 0. Oh, this way. If you just read this part, it's x is greater than negative 1. Oh, that's this part. And they kind of go together to make this. All right. Okay, so this one is going to start here at 0 and go over to 2. So from 0 is less than. I can't put equal to, even though it has a filled-in circle, because I already have the equal to here. X less than or equal to 2. Ka-ching! Stop me! If you are, stop and try it if you want. All right, so let's do this. So we're going to work backwards. I've got 3 equations. Now, if you want to, you can write all these out. Y equals 2, y equals negative 2x, y equals negative 2. Now, notice these are just lines. They're all lines. I don't know why I said that. They're just constants. Constant 2 or constant negative 2. Those are horizontal lines. So if you don't understand, one of the things we can do is this. You can just say, okay, I'm going to say, draw the line in y equals 2. There's the line y equals 2. Very straight and perfect. I know you guys are impressed. God, is it hard to draw. But I can only go from negative 3 to negative 1. Now at negative 3, it is a closed circle. And at -1, it is a closed circle. All right, so there, but I can't, so even though I drew that whole line, I can't use that whole line. I can only use those pieces. I don't know what that is. Let me do this one over here, -2. So here's the line y equals, oh, that's horrible, -2. But that only can go from 1 to 2. So from 1, closed in circle, because it's got an equal to 2, closed in circle. So I can't use that whole line. I can only use this piece, hence piecewise function. All right. Now y equals -2x. Notice it has a y-intercept of the origin, and it goes down 2 and over 1. So origin, down 2 and over 1. Let me do this one in a different color. Do it in green. Down 2 and over 1, down 2 and over 1, down, up 2. So if I was to draw that line in, it would look like that. But I'm only able to go from -1, which is right here. Oh, there's already a point there. And it's already filled in. It was filled in by the red. To here, it was filled in by the red. So, there it is. Ka-ching. All right, let's do this again. So, h of x. Now, I'm not going to rewrite those because that's kind of a waste of my time. Equals -x plus 1. So, I'm going to graph that piece right there. Plus 1. It's -x, so it's going down, going down, going down, going down, going down. Now, this is the equation of that line. Now, I can only go from -4, which is going to have a closed circle, to 0, which has an open circle. So here's going to be a closed circle, and 0 is going to have an open circle. I'm going to change this one to an open circle. And all the other points I'm going to get rid of. So now really all I need is this piece right there. First piece. Now we're going to go 4x minus 3. So this has got a y-intercept of -3 and a slope of +4. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. But I can only go from 0, closed in circle. Remember, x equals 0. Or x equals 0, and x equals 2, closed in circle. Oh, so that's that whole thing. Oh, that's nice. But that's it. I got to stop there. And close in circle. Okay, perfect. There it is. That's all she wrote, kids. All right, I'll be back. Darn! You guys are always catching me. Hey, there's that cool logo again. NK Krause. Oh, it's so cool. Absolute value is a piecewise function. What? Say, huh? What are you talking about? Oh, wait a second. Let's think about this. This, if I extended this, would be the line y equals x. This piece, if I extended this, would be the line y equals -x. Now, if I just use this piece, less than 0, open circle, and I use this piece, greater than 0, oh, closed circle going this way, that is an absolute value function. So, and we're going to use this idea later on when we go to start solving absolute value functions, because I think it's kind of fun. So absolute value of x is equal to -x, comma, if x is less than 0. Or it's equal to +x if x is greater than or equal to 0. Now again, it doesn't matter where you put the equal to because they meet at the same point. That's it. So we're going to write, oh, look at that, I stopped babying you. We're going to write an absolute value function as a piecewise function for this one. So we're going to use k of x. K for Krause. Oh, it's so exciting. So k of x is equal to, now we got two pieces. We got this piece and we got this piece. So, right. terrible curly bracket. I'm not good at these sometimes. Wow. And when I try to do them, I'm really not good at them. All right, that's not bad. All right, so let's talk about this piece. This piece has a slope of 2, so it's up 2 over 1, up 2 over 1. So 2x and a y-intercept of 3 plus 3. And it stops right here. Here's the breaking point at 1. So I'm going to use this piece only for x values less than 1. If I want to, I could put the equal to in that one. It doesn't really matter. There it is. That's that piece. Now this piece, piece 2, it's got a slope of, down 2 over 1. Down 2 over 1. So it has a slope of negative 2x plus, I have really no idea what it's, wait, hold on. Maybe we can just, so this is 5, right? We'll go up here. It would be 7. So it looks like plus 7. But let me make sure by using my point slope formula. No. Yes, point slope formula. So my slope is negative 2. And I'll pick any point. Let's just pick this one. It's 2, 3. My point is 2, 3. I just want to make sure that that is, in fact, the right equation. So I'll do y minus 3 equals negative 2x minus 2. So this is y minus 3 equals negative 2x plus 4, because it's negative 2 times negative 2. And if you add the 3 over, you do, in fact, get 7. So that is right. And I'm going to use this equation for all values that x is greater than 1. I'm going to start here, and I'm going to go in this direction. Now, even though it's filled in, remember, I got the filled in piece here. That wasn't too bad. Write a function for this piecewise function. All right, so we got two pieces, 1 and 2. So we're going to call this n of x for the numerator. N of x is equal to, all right, 1. It's got a slope of 1, up 1 over 1. So that's 1x, or just x, and a y-intercept of 0. So plus 0, or just that's it, y equals x. 4, now we start at negative 1, and we go to 0. So from negative 1 is less than or equal to x is less than or equal to 0. Now I don't have a choice. Since these pieces don't match, since these don't arrive at the same point, this one has to have the two equal to's in it. Only if they arrive at the same point, like this one, then you can make a decision where you're going to put the equal to part. But in this case, they don't come at the same point, so I have to do that. All right, so the equation of this line, it's a horizontal line, so that's just y equals 1, because that's the line y equals 1. So I just put a 1 down here. And that goes from 0 is less than x is less than or equal to 2. Notice it's got an open circle here. So it has to be not equal to. All right, let's take a look at M of, oh, they called it j of x. That's no fun. I called it, so we have to call it, excuse me, j of x. Excuse me. All right, so we're going to do now m of x. Boring. M of x is equal to, whoa, awful. Okay, so I'm not sure if you're going to get taken points off for being crappy at these, but try to do the best you can. We have two pieces, 1 and 2. So this one has a slope down 1 over 2. So negative 1/2 x down 1 over 2. So if I continued that, it looks like it would go through negative 2.5, minus 2.5. But I should check that. I should verify that. So let's see. My slope is negative 1/2, and my point that I'm going to use is negative 1, negative 2. So y minus negative 2, be careful, is equal to negative 1/2 x minus negative 1. All right, so this is a little bit tricky. This is going to be y plus 2. This is y plus 2 is equal to, now this is really a positive here, right? That really makes a positive. So this is negative 1/2 x negative a half times positive 1 is negative a half. Now, if I subtract 2, I get negative 2.5 or negative 2.5. So I was right about that one. All right, so where are we going to do that one? That one's from, that one starts here at negative 1 and goes forever and ever in that direction. So that's going to be for x is less than, let's put equal to on it, x is less than or equal to negative 1. This point right here. Negative 1 and going off in that direction. So now let's do the equation of this line. It's got a slope of up 1 over 2, 1/2. So it's positive 1/2 x. Now let's see what this one's y-intercept is. This one's y-intercept looks like, and it is, negative 1.5. So minus 1.5. But we're going to only use this starting here at negative 1 and going on for the, so x is greater than negative 1. Notice I put the equal to here, so no equal to there. All right, we're almost done, I think. Oh, getting there, kids, getting there. Bye. Okay, last page. Let's see how we do with this. I think I've got this blown up too much. Okay, if you wonder why I look at my watch all the time, I got a smart watch. Woo. It's always telling me stuff. Get tired of looking at it all the time, but it buzzes on me. My phone must be upstairs somewhere. Anyway, here, let's get going. We got 3 pieces. 1, 2, 3. Does it ever ask me for the equation of this thing? Oh, we're going to do the equation. We're doing it right now. We're going to do it, and we're going to do it right now. We're going to call this, we didn't use n of x earlier, so we're going to call it n of x. And we got 3 pieces. All right, so it's easy. This piece, it's got a slope of 1 and a y-intercept of 2. So x plus 2. This is a horizontal line at 2, so 2. And this one is got a slope of negative 1, and it'll have a y-intercept of 4. So negative x plus 4. Can't believe I didn't ask the equation of this graph. Weird. Anyway, comma. So this one we go from negative 4 to 0. And I'll include the negative 4 is less than or equal to x is less than or equal to 0. This one goes from 0 to 2. Can't include the 0 on this one. And this one starts at 2 and ends at 4. So from 2 less than x less than or equal to 4. So if you were writing the equation, that's what it would look like. Sorry about this. Every time I draw a 4, 90% of the time I draw a 4, I get some weird thing going on. Anyway, is this a function? Yes, it passes the vertical line test, so yes, it is a function. Is it a one-to-one function? Does it pass the horizontal line test? No. And I'm going to immediately bounce down here and answer this question. Is the inverse of this graph a function? And the answer is no. Remember, if it is not a one-to-one function, then its inverse is also not a function. So I might as well answer that question right away. Domain. It starts here at negative 4 and it ends here at positive 4. So bracket negative 4 comma 4 bracket. The lowest value is negative 2 and the highest value is positive 2. So it goes from negative 2 to positive 2. X-intercepts. Negative 2 and 4. Curly brackets because it's negative 2 and 4. It stands for a set of numbers, just 2 distinct numbers. Y-intercept right there. 2. All right, so where is this graph increasing? Remember, we're going to use x values. And it's increasing on this interval only. So from negative 4 to 0, it's increasing. So along this part, along this piece, it's increasing. Now, why negative 4 to 0? Oh, because we have to use the x value. So in between these two x values, it's increasing. Where is it decreasing? It's decreasing in between these two x values. So from 2 to 4, it's decreasing. All right, remember, This does not mean greater than 0. This means, or less than 0. This means negative. Where is it negative? And it's negative from here to here. Again, we're going to use x value. So in between these two pieces, it's negative. Now we can't include the negative 2 because at negative 2 it's 0. And remember, 0 is neither positive nor negative. So if from negative 4, we got to include negative 4 though. So from negative 4 to negative 2, but not including the negative 2. Where is it positive? Well, it's positive all along here. So between negative 2 and 4, it's positive, but you can't include the negative. You can't include the endpoints because they're both on the axes. So from negative 2 to 4. Where is it equal to 0? It's equal to 0 at 1 point and 1 point only, negative 2. Oh, and 4, excuse me. So negative 2, comma 4. Notice I put it in curly brackets because they are distinct points. What's the minimum of the graph? Now these, minimum and maximum, we're talking about y values. So the minimum of this graph is negative 2. And the maximum of this graph is positive 2. And that's it. All right, I'll be right back. All right, kids, one more problem. One more problem. You know we're going to write this function because it looks really cool. And you know what we should call this function? W of x. So I'm going to try to do it nice and neat over here off to the side. W of x. Now, why am I going to use W of x? Well, because it looks like a W. How many pieces I got? I got lots of pieces. 1, 2, 3, and 4. So, I can't believe I don't ask for the equation of this. I think we're going to do that in class. Okay, 1. It's got a slope of down 2 over 1. So that's negative 2x. Now, if I kept going down 2 and over 1, that would be at negative 2, so minus 2. And that's for x is less than or equal to negative 1. Now, I'm going to take this piece. It goes up 2 and over 1, so that's got a slope of 2x. It's got a y-intercept of 2, so plus 2. And that's between negative 1 less than x less than or equal to 0. I put the equal to on the negative 1, so I can't do it on this negative 1. This one has a slope of negative 2x, same y-intercept, negative 2x plus 2, and that goes from 0 is less than x is less than or equal to 1. And finally, this piece has a slope that's positive 2, so 2x minus, now this one also have a minus y-intercept, and it will also be minus 2, and that's for x is greater than 1. Well, that's a cool piecewise function. I'm liking that one. Is it a function? Absolutely yes. It passes the vertical line test over and over again. You can't draw a vertical line in this thing without hitting it and hit it twice. Is it a one-to-one function? No. Notice it fails the horizontal line test over and over again. So I can come down here and say, is this function's inverse? Is the inverse a function? No. Domain, negative infinity to positive infinity. Notice the arrows going off in this direction and in this direction forever and ever. Range, well, the lowest value is 0, and it goes forever and ever up, so bracket 0 to infinity. X-intercepts, all right, put them in curly brackets, negative 1 and 1. Y-intercept, 2. You can either write y equals 2, or you can just do it like this, 2. Where is the graph increasing? Okay, so it's increasing here and here. Don't include endpoints when you're talking about increasing and decreasing. So it's increasing from, remember, we've got to use the x values. So let me just use purple. From here to here, it's increasing. So from negative 1 to 0, it's increasing. Or, oh yeah, we got the or symbol again. From 1 to, well, forever and ever and ever in this direction. So from 1 to positive infinity. Now, where is it decreasing? It's decreasing from in this one and in this one. So let's take care of that left one first. Negative infinity all the way up to -1, or from here to here, from 0 to +1. It's increasing, or it's decreasing. Where is this value less than 0? Less than 0 means down here, below the axis. Well, nowhere, so empty set. Where does it equal 0? Oh, at -1 and +1. Oh, where is it positive? Oh, now this one's a little bit tricky. This one's going to be this one's kind of a pain in the neck. So, remember, it doesn't say equal to 0, so it says where is it positive? It's positive here. It's positive here. It's positive here. And it's positive here. So, but the only place it's not positive is right here at those 2 points. So this is going to be a triple. I just all of a sudden just branked. I'll figure it out eventually. All right, so from negative infinity to -1, it's positive. Or from -1 to 1, it's positive. Or from 1 to positive infinity, it's positive. Man, see, it's a triple thing there. Oh my God, triple domain. Anyway, what's the maximum of the graph? The maximum of the graph is positive infinity. What's the minimum of the graph? The minimum of the graph is 0. Done, bodied, over, crazy. See you, kids. Catch you on the plaza, please. Bye. Oh, hit the subscribe button, hit the like button, and of course you like our logo.